The National Map is a collection of mapping products and services produced by the USGS National Geospatial Program. The products and services are accessed via the Internet through service calls and graphical user interfaces. The National Geospatial Program has released a series of how-to videos for people who are working with the National Map data and services. The videos show how to use the services and interfaces to access data and tools for viewing, analyzing, and printing geospatial data. The training materials are a mixture of video and PowerPoint-based lessons. Lessons 1 and 2 serve as an introduction to the training materials. The remaining lessons are designed as quick how-tos and may be viewed as needed in any order depending on the user. Any use of trade, product, or firm names is for descriptive purposes only and does not imply endorsement by the U.S. government. Lesson 10C1, Importing Data into Global Mapper. Global Mapper is a software package for visualizing, analyzing, manipulating, and exporting a wide variety of GIS data. Its simple import and export capabilities allow users to quickly bring in data, including for this lesson, Lidar point clouds, and to visually inspect this data. By the end of this lesson, you will be able to open Lidar point cloud LAS data files in Global Mapper, turn on all or specific Lidar point classes, visualize the data in 2D and 3D, and change the visualization using toolbar functions. Note that in this tutorial we are using uncompressed LAS data, but the National Map also offers compressed LAS data, which is also compatible with Global Mapper. Subsequent lessons will cover the basics of LAS datasets and more advanced features such as editing LAS class codes, exporting LAS point cloud data into derived raster surfaces, and creating basic 3D analysis products. If you're interested in learning more about using USGS LiDAR data in other software packages, additional videos will show how to use LiDAR data in ArcGIS Pro and LP360. Before we begin, you will want to download some LiDAR data to use during our exercise. The National Map has a download client where you can find USGS products to include elevation data, such as LiDAR point clouds, at viewer.nationalmap.gov/basic. If you are interested in learning more about downloading products on the National Map, be sure to check out our training videos located at usgs.gov/ngp videos. However, for this lesson, we've conveniently packaged 6 tiles of LAS data into a zip file called USGS LPC CO SoPlat River Data for Lessons.zip and loaded it to our FTP site at rockyftp.cr.usgs.gov/training_data. Please navigate to this location and download the zip package. Note that this package file is over 700 megabytes and may take 10 to 15 minutes to download. After you've downloaded the LiDAR data, extract the zip file into a folder on your local computer to use during this lesson. We are specifically using Global Mapper version 20, but any version that is version 18 or newer should suffice for this tutorial. You should also have the LiDAR module installed. If you do not already have Global Mapper on your machine, and you work for the USGS, you can download a copy of the latest version of the software on the USGS Enterprise GIS support page. Work with your local IT team to install the software on your system. You can launch Global Mapper by clicking on the Global Mapper icon if it is present on your desktop, or by clicking Start under the All Programs and go to Global Mapper and select Global Mapper. Global Mapper has a LiDAR module that has functionality built into the software. However, it requires a separate license to use. Make sure that your license is active before proceeding. Under the Help menu, click on the License Manager. In the next screen, make sure the LiDAR module is toggled on, then click OK. Note that Global Mapper preserves settings from previous use sessions, so the defaults in your interface may differ slightly from what is shown in this tutorial. Getting data into Global Mapper is very simple. Almost every format of GIS data, vector, raster, and LiDAR LAS data, can be imported by clicking on Open Data Files, which can be accessed several ways. From the splash screen when Global Mapper is first started, from the top menu drop-down list under File, or from the Open Data Files icon. Today we will open files from the splash page. In the Open window, browse to the location of the Lidar point cloud LAS files that were downloaded from the FTP site. Click on the file named USGS LPC CO Soplat River Lot 5 2013 13 SDD 480395 LAS 2015 and click Open. Note that if your data aren't projected or don't have projection information in the data header, you will see a screen that prompts you to select the appropriate projection for your tile before continuing. Our data are already projected, so Global Mapper reads in the information from the header file and opens to the Lidar Point Options window, which is where we specify how to load the LAS data. In this window, you should see options to specify loading the LAS file as a point cloud or elevation grid, to limit the points that are loaded by your physical location within the bounding box, elevation, proximity to the mean, and point source ID, as well as options to select only points that fit the classification or return type. Once the data are loaded, Global Mapper provides the option to perform additional processing and filtering. Therefore, we will load our selected LAS tile in its entirety. Select Create Point Cloud to bring in the point data. We will make sure all point data are loaded by clicking the Select All button for point classifications and return types. Finally, click OK. After a few seconds, you should see the one tile of LiDAR data displayed in the View window. By default, Global Mapper displays the LAS point values by elevation using a rainbow color palette called Atlas Shader, where blue corresponds to the lowest elevation and red corresponds to the highest elevation values. Global Mapper provides additional color options via the Shader List drop-down menu on the Viewer toolbar, but we will keep the Atlas Shader default for this tutorial. Additionally, Global Mapper automatically displays data in the Color LiDAR by Elevation symbology mode. This option is controlled by the LiDAR Draw Mode drop-down. If this option is not already selected, choose it from the drop-down menu now. Global Mapper also automatically loads with a legend displaying the range of elevation values, as well as a scale bar. Additionally, in the lower right corner, Global Mapper displays the current scale, the tile projection, and the coordinates at the cursor location. If the Control Center pane is not already active, you can turn it on by clicking on the Overlay Control Center icon. Then change the scale by right-clicking on the scale bar and selecting Zoom to Scale. In the next View Scale selection window, type 20,000 and click OK. This LiDAR tile is an Apex open space park just west of Golden, Colorado. However, it is difficult to tell without a background map. Global Mapper provides access to map data from several online sources which can help. Click on the Connect to Online Data icon. In the Select Online Data Source to Download window, available layers are listed by theme. Under Popular Sources, select World Imagery and click Connect. The World Imagery layer is now added to the View window, enabling us to get a better idea of the terrain surrounding the LAS tile. You may notice that the World Imagery layer has drawn on top of the LAS tile. You can reorder the layers in the Control Center pane. In the Control Center pane on the left, you should see the name of the data that are currently loaded into Global Mapper. Now, in addition to the original LAS tile, we have a World Imagery layer as well. If your LAS tile is obscured, clicking and dragging the layer will cause the order of the drawing to change in the View window as well. Toggling the layer off removes it from displaying in the View window to the right. If you right-click on the LiDAR dataset, you will see a menu of options appear. Click Zoom to. This will recenter the View window on the LiDAR tile and is especially helpful if you have multiple layers displayed and you want to center the view on one layer. The View window defaults to displaying the full extent of the data. However, you can use the navigation tool to explore the data further. When the Zoom button is selected, you can use the mouse scroll wheel to zoom in or out at the cursor location, or click and hold the left mouse button and drag the cursor to zoom into an area. As you zoom in, you should begin to see individual points. Additionally, if you want to move around in the view without changing your zoom, you can use the pan button to maneuver around to a new area. Use the plus and minus buttons to zoom the current map view in or out at fixed intervals. The Restore Last Drawn View button returns to the previous zoom level, and finally the Full View Home button returns to the default map view. Global Mapper makes it very easy to switch between 2D and 3D views. Using 3D View to explore data is a good way to quickly do visual inspection of LiDAR data. On the Viewer toolbar, click the Show 3D View button. This will open a second window displaying the data in 3D. Double-click the ribbon at the top of the 3D Viewer window to align it beside the 2D view. Then click the Overlay Control Center icon to minimize the Control Center window. If you need to adjust the size of the 2D and 3D windows, hover your cursor on the silver bar separating the two windows until a resize icon appears, then click and drag the bar to resize the windows. The 3D window should open with data displayed on a black background. If needed, you can change the background in the 3D view window to a solid black color by selecting None, Solid Background from the drop-down options. You can use your mouse buttons to pan and zoom directly in the 3D window to explore the data. Click and hold the left mouse button, then moving the mouse around in the 3D window will rotate the last tile on a fixed axis. Clicking and holding the right mouse button and moving the mouse around in the 3D window will zoom in and out of the last tile. Alternately, if your mouse has a scroll wheel, you can use it to zoom in and out as well. Lastly, you can move the last tile to different positions in the 3D window by clicking on the mouse scroll wheel, then moving the mouse in the 3D window. As you pan around in the 3D view window, you will see high noise point classifications above the surface that are more obscured in the 2D view. Since we loaded all classification codes during the initial tile load, the view windows are displaying all data points, including noise. However, Global Mapper's Filter LiDAR Data tool makes it easy to filter points to only include classifications or return types of interest. Global Mapper provides multiple processing and analysis tools that can be easily accessed through toolbars. Two of these toolbars are specifically designed for working with LiDAR data, the Lidar toolbar and the Lidar manual classification toolbar. If these toolbars aren't already present on the top menu ribbon, you can turn them on in the View Toolbars drop-down menu. On the Lidar toolbar, click the Filter LiDAR Data tool to display only selected point classes or return types. In the LiDAR filter settings window, notice that all point classifications are currently toggled on. However, not all classifications are included in this dataset. Click the Disable All button to deselect all classes, then toggle on the ground classification. Also toggle on unclassified points, since most non-ground LiDAR returns are set to unclassified. Click OK. Notice that the high noise point classifications above the surface are no longer visible in the 3D view window. You may also notice that some of the red points in the 2D view window are no longer visible as well. Up until this point, we have been viewing the LiDAR points using the default Color by Elevation Symbology mode. The LiDAR toolbar provides several options via the drop-down LiDAR Draw Mode menu to symbolize LiDAR point datasets. The available symbology depends on the information contained within your last tile dataset. Select Color LiDAR by Classification from the drop-down menu. You should now see the tile colored in gray and brown points. To add a map legend that shows the point classifications, click on the View menu, Workspace Layout Options, and Map Legend. In the next screen, use the drop-down menu to select Display Legend Base Map on Loaded Vector Types, and click OK. Now the legend in the bottom right of the 2D view window shows that the brown points are classified as ground and the gray points are unclassified data. Now select Color LiDAR by Return Number from the drop-down Symbology menu. The LiDAR point data are now colored according to the return number. Most of the returns in the image are colored blue, which as we can see from the legend corresponds to a first return pulses. Now select Color LiDAR by height above ground. This may take a few moments to appear as Global Mapper calculates ground height and height above ground from the LiDAR point cloud on the fly. This may not be an exact calculation, but it provides an excellent first look at the relative height of LiDAR points. With this symbology, it is very easy to make out trees and buildings. Zoom into the lower left corner of the 2D example for a great view of the Mother Cabrini Shrine. Now select Color LiDAR by Intensity from the drop-down Symbology menu. This is displaying LiDAR points as a gradient from black to white based on the intensity of the return pulse. While displaying by intensity, it is now possible to make out a lot more detail of the surface, including buildings, trees, roads, trails, and part of a quarry. We will now view the LiDAR data by point source ID, but before we do, we need to change the filter to include all data points. Click on the Filter LiDAR Data button, select Enable All, then click OK. Now in the Symbology dropdown, select Color LiDAR by point source ID. This symbology displays points according to their source, which for this data corresponds to flight path. In this tile, we see 4 distinct flight paths. With this symbology, we can visualize areas where the flight paths overlap. You can save your workspace by either clicking on the Save Workspace icon or by selecting Save Workspace in the File menu. Navigate to an appropriate folder and save your workspace. This completes Lesson 10C1, Importing Data into Global Mapper. In this lesson, we discussed how to load a single LAS file in Global Mapper, add a background layer, use the navigation toolbar, and explore the data in both 2D and 3D views. We also learned how to filter LiDAR data by classification and apply symbology based on LiDAR point attributes. If you are interested in learning more about using LiDAR data in Global Mapper, please watch Lesson 10C2. Thank you.